Talk it out. We'll go like 15 seconds because this one's going to be quick. We are picking up this proof from yesterday. How do I know that side Alpha Juliet AJ and Charlie Kilo are the same? 15 seconds. I'm going to call on somebody. Talk. Lily, I want you to say that again if not everybody heard it. So check it out. We had a theorem right before this. And we're working out a new theorem right now. We are showing a different one is what's happening. We're just changing the order that we normally do it. Theorem 6.9 says the opposite angles are congruent. If we scroll up just a skosh, it was its own theorem and it was weird in here. 6.7 says opposite sides are congruent, right? So if it's a parallelogram, which we know it is, I'm just going to say, hey, that's not the same red, first of all. I'm going to say, hey, opposite sides congruent. And that's all that I need. I know that we're talking about a parallelogram. Opposite sides are congruent. And we're just going to mark this. Okay. Now, maybe we have something marked that we didn't really need. The goal right now should be for us to show opposite, or those two triangles are congruent to each other. Is angle JAS congruent to anything? JAS. And I'll tell you, I think it is. And I'm going to say it again. JAS. And I'm going to just label some of these. I'm going to say here's 1 and 2 and 3 and 4, just so we don't have to use all the ugly letters. What's the same as angle 1? Why? So I like one of those words. Are these angles right here that I'm marking? They're between this and this, right? Are they on the interior or on the exterior? So they're interior, and here's our transversal, and they're not alternate exterior then. What are they? Good. So I know on this figure, and I know that it's like I'm marking it up here. If you can't tell, I put an arc right here and here. They are the same. Are there any other angles that I can use alternate interior with as well? So we said angle 1 is congruent to angle 3. I'm good with that. Any others? 2 and 4 for the same reason. Okay, we have another pair of alternate interiors right here, 4 and 2. Angle 2 is congruent to 4. So we'll justify, as always, alternate interior, and we are just about there. I now have a ton of marks made on those two purple triangles. Can I say they're congruent yet? Let me rephrase. Why can I say they're congruent is, I guess, the more important question. We have 4 shortcuts because it's not a right triangle. What are the 4 that we talked about? All those A's and S's. So side angle side. Do we have 2 sides marked? So side is out. Since we don't have 3 sides marked either, side is out. So we only have a couple left. Angle side is one of them. Do we have an angle and then the next angle and a side? Yeah, and we could use angle side angle as well. Like either one. Doesn't matter. Drew, I'm going to put you on the spot though. I want you to help me write this congruence statement. I'm going to call the first one JAS. Triangle JAS. Juliet Alpha Sierra. Which triangle, Drew, is JAS congruent to? And I'm going to put dashes on these ones so that they look different. JAS matches with what? So you're close, but you're not quite. Notice what JAS does. If I go from J to A to S, it goes like that, yeah? So pause, because I think you're getting colder. Where did I start? What was a mark that I had on this angle? Single, double, or weird one? Where's the double over here? Good. And then I go from double to single to weird. Let's go double to single to weird. Must be CKS. It has to be. And that's the way that we can always work out that order. I'm just going to pay attention to the markings that I've used. So CKS. Carson, just in case you were zoning out, why do I know those triangles are congruent? We can use angle side angle. What was the other one that I could use, Ashley? And I think it's the one that Lily had proposed first. We could have used angle side, and they both get us there. Okay, so what? Why do I care that these triangles are the same? We're trying to show that JC bisects AK, right? If this is bisected, is there another way that we could word it? What would be the same if this was indeed bisected? AS would be the same as what, if that's true? AS and KS would have to be the same, right? And that's what like this is trying to show. AS is the second and the third location here. What's the second and the third here? So by that, I mean, here's 1, 2, and 3, right? The 3 points. AS is this one. So here we are on F for finished here in a second. AS is congruent to what's the second and third one here? KS. And maybe there's even more than we just said about our theorem. This is just what it means to, we'll just say, how do I know that those are true? These triangles are what? And these were the corresponding parts of them. CP, CTC. And are we done? Not quite. I need one more little tiny statement. What's this last statement we need to make? The fact that this was the midpoint meant that JC did in fact do what? So just like we have here, where it's what we're asked to show, this should be the last thing that we write. JC then bisects AK. Now, it is a bigger thing than we're going to write here. Let's think about how we want to define that. We're just going to say definition. That's what it means to bisect. We get two congruent parts. DEF apostrophe N is how my shorthand for definition, just as a reminder. And then we'll box and square it. Now, there's a bigger piece hiding here than what we just proved. And before we dig into that bigger piece, feels all right, feels awful, logically this proof. Thumbs up says it feels perfect. Thumbs down says what the hell's going on, anywhere in between. Okay, now there's a bigger part here. JC did bisect AK, right? Does AK also bisect JC? And we can see that because if I wanted that to be the truth, it would need to be that JS and CS are the same. And we'll just check. JS and C, they are the same. So this was really just to build up our next theorem. We normally present theorem and then prove it, but we just said, hey, let's just see if this does happen because it kind of looked like it happened. So all of this was the proof, and this is different than we normally do it, but this was indeed the proof of our next theorem. So we'll just say proof of, and what's our next theorem? I just look in the number. I don't remember. Is it 0.10? Is the next one, last one 9? So this is the proof of theorem, 6.10, which is what we're about to prove. That was much harder to write this way than I was anticipating it to be. Ashley, no smiling, okay? Just no joy. Cool, thank you. All right. I am messing with you. I'm pretty sure you know that, but just to be clear. Last theorem, and then we can do some problems with these. Theorem 6.10. And it doesn't get its own name. I don't know why these ones never name themselves, but it happens. And I'm going to try very hard not to kick the thing today so it doesn't die. The recording is what I'm talking about. All right, we're in weird. I was trying to figure out what we're doing, but I was in chapter 2. It didn't make sense. So let's check this out. 6.3, theorem 6.10. I just want to make sure I get the right theorem in the right place. So given, and we can name this if you want, this is the diagonals or the diags of parallelogram. Or parallelograms, because it happens to all of them. All right. So as we're looking at these lovely parallelograms, Here's our last theorem that we get, and then we're just going to do some problems together. If we are looking at these, we're just going to say, given any parallelogram, the diagonals bisect each other. The diagonals bisect each other. Okay, every single time, and we just proved that this has to be the case using congruent triangles. So as we're going through these, rather than just saying here's a theorem and a problem with it, and here's a theorem and a problem with it, we are just going to try to play around with a few problems and have to pick out the theorem. Now, something that I would always recommend doing, and it's not something that we necessarily do together, but there's like 3 or 4 theorems just in this section, right? A quick summary of what happens with it would not be a bad idea. Now, I'm not going to write it for you guys right this second unless we want to, but let's just think about everything that we summarized. If I give you a parallelogram, we know the opposite sides, 2 things. 1, they're parallel. That's just a definition. What else are the opposite sides? They're congruent. What are the opposite angles on a parallelogram? They are congruent. What are the diagonals? What do they do to each other? Who's cooler, me or Mrs. Holloway? That was the right answer. If we'll all take a quick glance. Nobody fell for that just now. Ms. Holloway, what can I do for you? How much money do you have? That's fair. You guys want to see something crazy? Watch this. I didn't read any of this. Didn't even look at what it is. I'm just signing blindly. That is trust. Good. All right. So here we go. We're going to use those. I would summarize those. This whole section on your note card can be written in those 3 or 4 statements, depending on how you want to word it. So let's check out a couple of them. And I wish that I had the ambition to like give you guys printouts for every section, depending on the problems. But I don't do that because they change. Like different classes get different problems depending on what it is. So let's take a look at some of these. We are going to do a few problems together, but we're going to use our textbook to help us out. We're going to start right here. That's how I see if I don't wear my glasses, just for the record. Not this close, I wouldn't. Okay, for 5 and 6, we are going to use this lovely parallelogram ABCD. Now, I'm going to copy and paste this. I want you guys to draw this. You don't have to be super specific. You don't have to write all of, I'm going to zoom out in there or back up and then I'll zoom in. You do not have to write down word for word exactly like this, but we are going to use parallelogram ABCD, and we're told that DE is this. Let's play around with these ideas. I'm going to label it a little bit differently, but we are going to knock this one out. Find BC and BD is our goal. So we'll just do this real quick, and we'll use a little editing magic. So example, find BC and BD if DE is equal to x plus 2. That's our goal. Now, I hate that on a white background, this is what it comes out to when I put it up here. It kind of bugs me, but we'll be all right. All right, I'm just going to get rid of all this. Now, there's one thing that drives me crazy about this, but I'll give you guys a moment. Picture doesn't have to be perfect. Can you all read this red writing here? Okay, cool. We'll pause it and let you guys catch up. We just need the parallelogram and something to say what it is that we're trying to find. 60 seconds, talk it out. I'm going to call on one of your random groups. We can make group names. We have such a small class. We could have like a whole season and keep stats throughout. We'll think about that. You guys go. 3 things that we know are true about parallelograms. What do the diagonals do to each other? Can't use that. I mean, I could. I know that this is also x plus 2, but I don't know that that does anything for me. But it is true. What do the opposite angles of a parallelogram do? They are congruent. So I'm not going to mark them, but I know that that and that match, right? It has to be the case. There's one more that we're going to use. The opposite sides are congruent. Now, This is the most common mistake that I see in geometry, and it's not even a math mistake, it's just to pay attention to what you're doing. Are all the things here angles or sides, and how can I tell? How can I tell they're sides? Because people get this goofed up constantly. So not like that's a good indication, but it's not guaranteed. On the outside is a good idea. If they were angles, how would we specify that they're angles? What would they all have? If there's no degrees on them, they're not angles. Like use that. So there's nothing that adds up to 180 because we're talking about sides. However, I think that I can with confidence, and you don't have to write all of this because you're just going to do the math, I imagine. But Carson, BC guaranteed is congruent to what? Why? Awesome. They're opposite sides. This and this are congruent. And since they're congruent, we know that the measures are equal to each other, which means what's BC in this picture? 3x minus 2. And Tody, what is AD? What is the length of alpha delta, AD, that we have written on our picture? Love it. X plus 4. What's the value of doing this? Rephrasing. How does this help us solve the problem? What's this going to give us, Raylene? Let's finish this one first. This gives us x, right? And once we have a value for x, I think we can answer everything else. So Drew, help me solve this for x. I'm going to do 2 steps in one here. You want to get all the x's on the left or all the x's on the right? Okay, so how do you move this one over? Or get rid of it on the right side of this equation? Good. And love it. And then how do you get rid of this plus 2? Or dang it, how do you get rid of this minus 2 here? Plus 2 to both sides. How many x? Try again. If you have 3x and you subtract 1, good. And that's all that's over here, equals, they're gone, 6. What's x? Divide by 2, right? Okay. Camille, I have a question for you. Where's the 0.5 come from? Okay, so that will kill it. Your approach is fine. Your number is just bad. Okay, awesome. We now know x is 3. What were we actually trying to find? So let's see. BC is this one up here, right? So if x is 3, we can just plug and chug. BC is 3x, and I'm going to put parentheses here, minus 2. What did we just say x was? And what's 3 times 3? Minus 2? Check it out. 9 minus 2 is 7. BC is 7. There's one of our answers. Now, they don't specify here. I'm just going to call it units. Cool. And we're also trying to find Bravo delta. Ooh, what's Bravo delta? It's this whole thing here. Somebody's going to try to answer 5 or 5.5, depending, and you're going to be wrong. Why is it not 5? Yeah, if I do x plus 2 for either situation, and that was good that we did that in the end, apparently, but if we only had this one, this length is 3 plus 2 is 5 here. And then what do I know that this length is? Because it's the other part of the diagonal. If this is 5, then the diagonals do what to each other on this shape? So if that's 5, what's this? And the whole length? Boom, and we're done. Being able, like, none of the problems that we do in here, and this is a weird thing about geometry, nothing mathematically that we're going to do is going to be like beyond what you can do mathy. The challenge is being able to find the right tool and to use it.
Wait, how is DE congruent to DA?
Say that again.
How is DE congruent to
DE, and where do you see that it's the same as DA?
Oh, BA.
BA. By coincidence.
Oh, that's not.
It just happens to be the size of this one. Yep, it's pure coincidence. This 5 never showed up, right? We didn't have to use it. We didn't get to use it. We don't need to use it. It was a piece of extra information. It just happens to be that in this one, apparently if you give me a 5 by 7 parallelogram, then half the diagonal is also going to be 5. Cool. All right. Doable? Super hard? What do you guys think? Okay, one more that I just want to look at, and we're not going to physically, maybe we will. I don't need us to write this one and draw it because I'm just going to do a quick check. We might overlap today with some time for homework, and then we'll start looking at something. What are those? How would we approach this? We're trying to find NPQ. So if we were trying to find this angle, I just want an approach, not an answer. Talk with your neighbors, 30 to 60 seconds. I'm going to call on somebody that's not Lily. Cool. Talk it out. How do we find this angle P up here with what's given? I'm going to record so that people can see the homework. I'm going to let you guys pick. When I write the quizzes, they're essentially tests, like just less material. I think sometimes my quizzes go a little bit too long. Do you want a longer quiz that gives you more chances to do problems? So like I give you 2 of each type is what I would normally do. Just say, here's one and another one, show me you can do it in both situations. And give you the regular quiz. It takes like 30 to 45 to 60 minutes, like the whole class. Or we can just do a super short quiz. But if we do the super short quiz, it means that there's like one shot at each type of problem. Do you want the short quiz or the longer quiz? Drew wants the short. Anybody else have a preference? We'll try a shorter quiz tomorrow. I'm going to aim for like 20 minutes instead of 55. Okay, 20-minute short quiz, which means here in a minute, we are not going to start the next section today. What do you think we're going to do with the remainder of time? If you finish these, what might you do? Bet. Cool. Hella good, right? Hella money. Is that what the phrasing was? Hella cash. I don't remember. I don't know. It's something. All right. Deal. So for every quiz that we take in here, Jordy, anything that you want to put on this note card, front or back, you're welcome to. Like all the theorems and stuff, I don't want you to just memorize things. I want you to be able to do them. So it is not required, although I could require it so that people do it. I'm not going to this time. It's not required, but I will not give you help with theorems that you could have written down. Cool. Mm-hmm. You're welcome. Stucky. On 19 or 18? So what are the values of AB? So this side, and DE, which is just this part. Oh, so much easier than you think. No, it says AB and DE. Oh, I see what you're saying. On number 18, just to be very clear, alpha echo is 19. That's what they're giving you. Just that little part of it is 19. And if you want to draw on that one, if you guys would, please, I'm going to have you make a mark in your book. And we'll try to do this fairly consistently, but it doesn't always happen. On number 19, if we're looking at it, I don't want you to have the answer, so we'll just do it like this. Okay, on 19, do me a favor. Just kidding, that's the wrong one. Here's 19, right? Okay, on this, what I want you to do for me, and I would appreciate it, in your book, physically make this mark. For 19, I would do that. Like, let's make very clear that it's just AE is what 19 is right here. So it's weird because we're on, actually number 18 is the problem that we're on, but the 19 is only referring to alpha echo. Cool. All right. 20 minutes to work on your homework and your note card. Hopefully don't have to do anything out of class today, but I'll get some quiet tunes going. Anybody have a preference? Death metal? So you do have a preference then, based on that look. Let's see here. How old are you guys? 15 and 16?